Dr. Steve Warren, thank you again for letting us document this. Tell us a little bit about yourself.
Yeah, hi, so I'm Dr. Steve Warren, Stephen Warren, professor of genetics at Emory and currently a researcher at HHMI.
So, what is that?
Yeah, so it stands for the Howard Hughes Medical Institute. I joined after my publication last year.
And you're here today to present your research on Fragile X, correct?
Yes, sir.
Do you mind giving us a brief history of Fragile X?
Not at all. So Fragile X syndrome was first discovered and observed clinically in 1943 by J.P. Martin in London. He described a form of intellectual disability that appeared to be inherited in a family pattern. However, they didn't identify the exact genetic cause. Flash forward to 1969, Dr. Herbert Loves at the University of Colorado noticed we'll call it a fragile site on the X chromosome in individuals with inherited intellectual disabilities. Various studies throughout the 70s validated this research, showing there was a unique set of symptoms expressed by individuals with this site on the X chromosomes. And in the late 70s, Dr. Grant Sutherland confirmed the presence of this fragile site under folate deficient conditions.
And then what?
Well, that's why I'm here.
Okay.
I'll see you out there. Ladies and gentlemen, allow me to be the first to welcome you to the 1992 National Fragile X Conference, where we are joined today by Dr. Stephen Warren. Dr. Stephen Warren earned his Bachelor's of Science in Zoology in Michigan in 1976 and proceeded to complete his PhD at the University of Michigan as well. He completed his postdoctoral training at the University of Illinois. He is currently an associate professor of genetics at Emory University, where he recently received the Albert E. Levy Science Faculty Research Award. Dr. Warren is an expert in human genetics, and we are honored to have him present this year at the National Fragile X Conference. Without further ado, please welcome to the stage Dr. Stephen Warren. Many of you have read my papers, many of you are here for other reasons. Regardless, for the sake of time, I'm going to dive really quickly into what my team was able to discover and the breakthroughs that we had over the past few years, and then I'm going to open up the floor to Q&A from the audience.
Please state your full name for the camera.
Hi, I'm Carlos. I'm Stephen's cousin. I didn't have anything else going on today, So it has been the consensus up to this point that Fragile X syndrome was caused by a structural abnormality on the X chromosome.
So are you also a researcher?
No, I'm a sales associate.
What company?
I work for a telemarketing agency. We knew this was true by looking at patients with a fragile site on their X chromosome and characteristics expressed by those patients. These include longer faces, larger ears, flexible joints, and even some intellectual disabilities. We just didn't know what the structure was. What I've done in my most recent publication is locate the gene responsible for this disorder. Fragile X affects 1 in every 468 men and 1 in every 151 women. It all starts from a repeated expansion of the DNA sequence within the FMR1 gene. This expansion silences the development of a protein crucial for neurological development. This has allowed my team and I to shift our view from merely the symptoms to the underlying causes. It is at this time that I would like to open the floor up to questions from the audience. Hey, Dr. Warren, I'm a biology student here in Ontario. Could you please explain in more detail how CGG repeat expansion in the FMR1 gene leads to the silencing of the gene that affects protein production? Hey, yeah, great question. So typically, the gene has anywhere between 5 and 44 CGG repeats. However, in a case like Fragile X, the number jumps up to 200 plus repeats, reaching a level known as full mutation. This expansion signals the silencing of the FMR1 gene. When the FMR1 gene is silenced, no protein is produced. When no protein is produced, the brain's wiring doesn't fully function properly, leading to behavioral and developmental issues like we discussed prior.
Did you get all that?
No. So how did you and your team determine the correct amount of CGG repeats that lead to the expression of the disorder? Excellent question, sir. So for our analysis, we used family studies, molecular genetics, and linkage analysis. We noticed early on that there was definitely something up with the amount of CGG repeats that a human being might display. For example, an individual with between 55 and 200 repeats would be known as pre-mutation. And right here, as you can see, if they chose to reproduce, they could have children that might have the full mutation. Could you please speak to how Fragile X is inherited? An excellent question. Take, for instance, an example where the father is the carrier of the mutation on his X chromosome. Thus, we'll identify that as XY, and we'll circle his X so that we remember that the mutation is on his X chromosome, whereas his spouse is XX. Now, their children have 4 different possible outcomes. They could be either XY, XX, XY again, or XX again. However, in this instance, the father is only able to pass down his Y chromosome to his sons. Thus, the mother fills in the rest of them there. In this instance, however, though, the father is only able to pass down his X chromosome, the mutated chromosome, to his daughters, making it a guarantee that his daughters will have the mutation. His daughters, however, have a lower chance of displaying this due to the X inactivation. But we don't have time for that, Mingoni. Moving on to the next scenario would be if the mother is the carrier of the X mutation. Thus, she will be XX, and we'll circle this here to signify that that is the mutation gene or chromosome. And there's the father. Again, their children could be either XY, XX, XY, or XX again. However, this time, there's a 50-50 chance for any given of the 4 to carry the mutation on. This is because the father will pass down his Y, and the mother is guaranteed to pass down at least one of these X's to any of her children. Thus, this person could get it, or this person could get it. And maybe these ones, it happens to not get it there. Thus, there's a 50% chance that any of her children will carry on the mutation. Thank you all for coming out today. Have a good rest of your day.
Are you proud of your research?
Am I proud of my research? Sure, yeah, but this isn't about pride. Medicine is a science. It's a method. And it remains a method until you see someone's life changed by it. Maybe they're a student, an academic. Maybe they're a parent. Maybe they're someone whose whole worldview has been changed. Maybe they're a parent who's watched their child's whole worldview be changed. I don't think it's a method at that point. I think if you're looking at it for a brief moment, it almost becomes suspended, if you will. In that moment, it becomes art.